Here it is a very interesting question from GATE 2018. So two battery banks are given 50 volt and 150 volt. They are connected through a converter, and the switching frequency is given as point. Switching the duty ratio is given as zero point 0.4, and frequency is given as switching frequency is given as 5 kilohertz, and we need to calculate the power transferred from B1 to B2. That means the power transferred from B1 to B2 50 volt 150 volt. Now by the look of the converter, the inductor is placed in series with the source. That means it is a boost converter. Now let's check if the operation is continuous or discontinuous. So we know that in boost converter, the output voltage is nothing but P input by 1 by D. So D is given as 0.4, P input is 50 volt, T 0.4, it is nothing but 125 volt, but this voltage is less than the given voltage, which is 150 volt. That means the operation is discontinuous. Now let's try to draw the waveform of the inductor current. So first of all, during T on, the inductor will charge like this. Now after that, as the switch is opened, the inductor will discharge to the load, and as the conduction is discontinuous, that means it will extinct at less angle than T. That means beta T. The beta is extinction angle, so this is T. Now let's say the IP is the peak inductor current. Now we know that the inductor voltage is L di dt. So here the di is nothing but IP minus 0. That means IP, and dt is T on minus 0. T on, and PL during T on 0 to T on, as the switch is opened, the input voltage is around the inductor. That means the PL is nothing but PS, which is 50 volt, and we can write 50 volt, or let's say PS. Now the D is given as 0.4, so we can calculate T on from here. .4 by F. F is given as 5 kilohertz, so we'll get 80 into 10 to the power 6 seconds. So by placing the value of T on here, and we can get IP 50 by 5, 10 to the power minus 3, 50 into 80, 10 to the power 6, and the value will be 0.8 ampere. Now during T off, after T on, during this period, that means during T off, the voltage around the inductor is PS minus V output. So during T off, during T on to beta T, the voltage, inductor voltage, is nothing but Vs minus V0. Now we know that the inductor voltage is like this. Okay, now we know that from voltage second balance we can say that the average voltage of an inductor during charging and discharging is 0. That means VL dt 0. It is very important. This is called voltage second balance. Now we can further write that P as T on plus during T off the value is Ps minus V0 and the time period is beta T minus T on equal to 0. So from this we already know the value of Vs and P0, and by writing all the values we can get beta equal to 0.6. Now to get the average inductor current, we have to calculate this whole area during a time period. That means the average inductor current will be the area under this curve by total period, which is T. Okay, so the area of this curve will be Ip into half Ip into the time period, which is beta T. So half beta T into the peak current Ip and T. From this beta we know that 0.6, T will be cut out like this. So Ip value we have calculated 0.8 ampere. We can get the current will be 0.24 ampere. So this is the average inductor current. Now as we get the average inductor current, so the power transferred from B1 to B2 is nothing but PL average into PI average. So power transferred is PL into IL. Now PL average, as we need to calculate the power transferred from B1 to B2, so BL average is nothing but 50 fold. So 50 into 20.24, so the answer is 12 watt. So this is how this type of question is done. It is not simply you can use any equation. We have to draw the curve, we have to check the if it is continuous or discontinuous, then we need to use voltage second balance. After that again we have to calculate the average inductor current, which is very important, and then we can get the power. So this is how this type of question is done. Thank you.